people can hear us now. Yeah. Yeah. Hopefully. Well. I mean, it would probably be helpful not to hear myself. I labeled this one as visual ASMR. I don't know if that will do anything. Are you still hearing it echo? Ah. Got it. Is it the one on the browser? Like inside the stream? Yeah. I suppose I could do the things I normally do to make the image look good now. Well, they supposedly did maintenance on the instrument, but when the guy was here, he asked me what kind of, like magnification can you get reliable pictures from? And I said, I don't know, like usually like 130 is pretty good. And I said I sometimes have managed to get like 160, but I kind of have to work on it a lot. And he's like, oh, okay. I was like, what should it be? And he said, oh, our standards are like 100,000. So I was like, oh, well, I mean, I can do better than 100,000, so. Yeah, almost twice as good as that, but, it requires some work. Hey, Micah. Really? That's interesting. I can't hear Pack in the stream. Oh. Well, that's normal. Let's see. Is that always going to be the case? I can edit your volume. I don't know. Am I one of them? We could do it in your Discord if you want to edit my volume.
It doesn't work in my Discord.
I wonder.
This is just barely audible. You wake up and talk for a little bit and see if you can let us know when you can hear me speaking. Maybe. So, I'm gonna send an announcement to my friends who Plankton people here locally and see if they're joining, checking out the stream since it's all gonna be San Francisco Bay Plankton. Well, is it
It's just San Francisco Bay. Can you still not hear her, Micah?
Maybe you can hear me. So, great. So I'm really excited. I hope this is Plankton. If you can find a Earthrom, which is like the Tic Tac program, so he's spectacular. I love those. Not yet, he says.
Huh. Wonder why that's... Yeah, I can hear you. I wonder why this is the case. I haven't changed the settings at all from when John was on. And... Huh, that's weird.
It's not me, right? I mean, you can actually hear me.
Yeah, I can hear you.
Hard to hear.
No. Okay. So, let's see. I wonder what the problem is. Because you light up like you're speaking.
I light up. It's like that. I see him. Makes me do that.
Huh. This-
I could just read your chat quietly to you in your ear.
Let me see. That would be kind of fun, but
But not necessarily useful.
I mean, the rest of the time I'm talking to myself, but I'm normally talking to myself, so I guess it's about the same. Let's see if I paste this in. I don't know if that changed anything. Other than...
Red Shrimp is here. Red Shrimp, can you hear me?
I don't think she can. Let's see. Oh, I know. No? It's in the right... I wonder if... Yeah. I don't understand why this doesn't work with you, but it worked with John. But they can hear me, which is the weird part, because I'm coming through the same app as you. So... Yeah. You're a ghost.
It's coming through okay at your end.
Yes. Maybe I will... Let's see. I'm gonna kick you out and bring you back in and see if that does anything.
Okay, bye.
Well, first I have to figure out how to do that.
Here, I can just walk away.
Oop. I need you to be somewhere I can grab you. Okay, there you go. I don't know if that changed anything for people. Oh, yeah. Hi. Anyone out there can hear Pacific Plankton yet?
Because I'm here too. If
That's super weird.
It is super weird, you know, super quiet, super weird. What is she using? I'm using the microphone and But you
Yeah, I can hear you fine.
try screaming.
No, don't do
I
that.
can't scream.
You're in my ear.
Look at this whispering. Not screaming.
Yeah, I don't know. Well, you can just read stuff to me, I guess, and then I'll tell people what you said, or you can tell them what you said. You're my voice to text, or text to voice. Yeah, it could be. I mean, I don't believe in ghosts, but oh, I don't think it's the SCM. I didn't know what this shape is. Oh, is this a girdle view? I think maybe it's just a diatom that got folded. Yeah, she's all the way up in Discord. That's the problem. Like, her volume's all the way up in Discord. I don't know. Micah, join the Discord, and then I'll drag you in and see if you can be heard. That would be interesting. Maybe she's not real. Maybe... What is this? Maybe she's just a voice in my head. What the heck is this?
It looks like a radiolarian Micah's in the Discord, I think you have to find him.
I do. Alright. Now what happens when Micah talks? Oh, I gotta unmute him, I forgot. I know. That's what I do. I just suppress people.
So I can hear you, Micah, because I'm in Discord. Can you hear me?
Huh. You're not in my head then. I wonder what the problem is. I don't know. That's a bad sign. Everybody's extremely quiet. Hi. Well,
I think it's actually it looks like a radiolarian with some content on it too.
it's also there's like a Melisira with a donut hole in the middle. Okay. I mean, I already have a job. But okay. What are these little things on here? I don't know. I need to work on this image a little bit. I feel like it needs adjustments. Okay. I'm gonna do some auto magic gun heating and column centering and some other things I normally do. And this is interesting. So everything in the widget for the voice widget is set up correctly. And in fact, in the voice widget, it shows Mica and PacificPlankt, and it does have you like constantly on for your microphone for some reason, Pack. But Mica, when you talk, I think yours just lights up only when you talk, right? Yeah, yeah. So that's weird. I wonder why this worked when we tried it one time and then now it's not working. It's the Discord stream kit. And as far as I can tell, everything is set up. What about this? Keep talking. Stream kit. Because it doesn't actually show you as your voice moving when you talk. Yeah. Oh, we're zoomed very close last. I'm just trying to get the image. We're just starting out, so I'm trying to get the image warmed up correctly. So for right now, it was working on the gun heating, and now that that's more or less stabilized, I normally go through this steps a little bit earlier, but I was trying to get the sound working. So then it does some auto gun centering, and then I'm going to do a little bit of adjustment to the to the wobble and the stigmation, and then we'll be able to see things clearly. But for now, it's still tweaking the image a little. It's taking a lot of time to accomplish easy tasks. Ah. Yeah. Can you give him a shout out? It's taking a really long time to do the gun centering. He supposedly went through and did some manual adjustments to the column as well, but I wouldn't think he would make it worse. I mean, they're an engineer, so I kind of feel like they should know what they're doing, but this is like super weird. Let's see. Well, there's a lot of these guys hanging out in here. This is Bacteriastrum, right? Is that what that is? Hang on. It has like a wavy looking spines.
Yeah, if you look out to the edge of it, like further out, like follow the spines out. Like the spines are drawn further out by rain. Yeah, see that?
This ring? I don't see a ring associated with these spines. They just go out from the middle. Yeah, I'm not sure what that is actually. Maybe a girdle band, yeah. The surface is super smooth.
Maybe it's covered. It looked like under an SCM.
Yeah.
Because it has the connections. Where the spines attach.
Here, they have little connections.
Last while, this wants a picture of that place, and so do I.
Okay, I can get a picture of it. Hang on, I still need to make some adjustments to the image though. So, I'm not happy yet.
It says the text to speech ones specific.
Yeah, I know. Isn't that weird? Well, they can read you. Yeah. I think it probably is just something that landed on the slide, and then this is a separate thing. Okay, let me work on... I'm going to come back to this. I won't go very far from it, but I need to find something with some texture. Right. I need to find something with holes so I can... I'll come up to this guy here. And I can look at these started processes on here because I need to have something to fix the image a little bit. Okay, start with the wobble. Ah, you see how bad that is? Yeah, what I'm doing is trying to fix the wobble of the beam. So I'm manually centering it. And I'm actually just trying to do it in a very coarse fashion first because that image was very not centered. Actually, it's still got a whole bunch of problems. One of which is the beam intensity is too high. And now it's a little bit better. So this thing that's going on here in the middle is trying to, the image should be stable in the middle of there. So if, like where my mouse is, it shouldn't be moving around, but it is. Just a little. The less it moves, the better. So it's still wiggling just a little, but it's way better than it was. And then, yeah, it was moving around quite a bit. And then I need to fix the stigmation as well. So that's this other aspect that needs to be adjusted, so we can actually see something. It has to do with the way that the, like if you have a sense of what's going on, the instrument's moving up and down a little bit, just very subtly, and it allows us to figure out what's in focus by, so if it's a little too low and the beam is wobbling, it will shift. And if the beam is basically dead center and it lowers and raises, what happens is it just goes out of focus, right? So if it's just going out of focus, that means that the beam is straight, it's hitting the surface where you're expecting to hit it. And so when it's wobbling, what happens is the carousel's moving up and down just a little bit, and it's like the beam is coming in at an angle, basically, so it sort of stretches the image sideways. I have X and Y controls when I move it to actually make adjustments to it, and the stigmation is sort of similar. It's like focusing the beam on the spot where you want it, and it's also a little bit better than it was. It's still not great. Like, that image is still not great for me. But at least I can see things. So. It's not that. It's like 4.9. So I'm usually at around 5. It's pretty close to where it normally is. But that shouldn't make a difference for like this part. So, but I can fix the wobble a little bit by zooming in, getting a little bit closer, and then redoing the wobble. So it's gonna, you see how it's just kind of drifting a little bit left and right still. And a little bit. It's more like when you go to the doctor, the eye doctor, and they want you to know which is better, like this one or this one, this one or this one, and they flip through the lenses. It's kind of like that, except for I'm just tweaking it a little bit at a time. So let's see how good that is, how much of a difference that makes when you're there. Now you can actually start to see the structure of the actual object that I'm trying to get into perfect focus. And this is the part that usually just, it takes a little while to work with the image to get it exactly where you want it. And what I'm mostly doing is looking at areas where there's high contrast, and I'm trying to make sure that that contrast is as defined as it can be. So like in here, there's these little tiny holes that are U-shaped, and the closer it gets to being perfect, the more clear those little holes will be. And then I can slow it down, and we ought to be able to see that the surface is covered with a whole bunch of little tiny salt and pepper shaker heads. That's what these things are right here, the cribra. And the image is still just a little fuzzy for me, but I feel like now I'm nitpicking, right? Now I'm like, I might take like a long time to actually get that image a little bit better than that, but it's pretty good. So we can leave that, and I can come back to this thing, which is our object of interest, unknown object of interest. And maybe get a good picture of it, now that we can actually see stuff. It probably does, but I'm not totally convinced. Let's see. We slow it down. I mean, if your question is it actually a diatom? I don't know. It doesn't look super diatom to me, but so this is, I think, the live material from March 1st. Yeah, from March 1st. So it's totally feasible that this could be some other kind of organism. I'm not sure which kind. It doesn't look like a diatom to me, though. These things, they look like little filaments to me. They don't look like diatom pieces. It's kind of ravioli-like, if ravioli had tentacles. Okay, let's look at it here. I mean, you can see diatoms have holes, right? And they're really distinct, and they have structures that you should be able to pick out. So I'm going to guess it's not a diatom. The what is it category, I don't have an answer for, but sometimes that happens. Especially in this live stuff, you know. I mean, these things look really like... That's definitely not diatom looking. We're going to zoom in and look at this in a minute in here. Because it looks like they look like, you know, like distributor caps on a car. And then it's got a long cable. And then it's got this structure out here. I can see one of these things are broken right there. And another one's broken right there. They just continue, stretch out. I don't know. Could it be one of your jellyfish? Well, I don't know. I don't know what it is, but I'm going to get a picture of it, and then I'm going to zoom in and take a picture of it a little closer. Mysteries are okay. I like mysteries. Hey, OpenSet, how's it going? We're looking at Mysteries of the Deep with PacificPlankt, who is talking but can't be heard by anybody but me, apparently. Mysteries of the Shallow. Right. Hmm. Maybe. Possibly.
To use as oblique lighting on the microscope.
Oh, wait a second. That might have changed things for us. Maybe they can hear you now.
Can you hear me now? You can hear me now? Wow! They can hear me!
Okay, hang on. Let me play with the settings just a little bit.
You'll have
So,
to tell me what you did later, and then I can try it next time on mine, because that seems like a lovely solution. Hooray!
okay. Keep talking.
Okay, so I'm not just a ghost in the chat anymore.
There we go.
Now I'm a real voice.
Yes.
Hooray! Andalor can hear me. Yay!
Yeah, good. Now it's not like I'm talking to myself anymore. I only seem half crazy now.
Better half crazy, right?
Oh, no, it's a diatom. Right here. Those are setae.
Yeah, they've got the jagged
Yep.
kind of serration on them.
Yep.
So
It's probably bacteriastrum.
it could be, although honestly, I've never seen Corethron this close. That's why I was asking. But if this is the live material, it might still have, goo on the outside. Oh, Andalor, do you hope to inhabit a microscope in a next life? I kid. Andalor, it would be interesting to be the voice in the microscope. Right? If we can upload our consciousness in the future to extend our, I don't know, if you can call it life, I could be the voice of a microscope.
That sounds pleasant.
The question is, could you see what was happening on the microscope as the voice and help people make it better?
Well, I hope so.
'Cause that would be fun.
I mean, what are these? These I get. What are these things? Super weird.
So cool. They look like they're holding on to something.
Like little crab claws? Or grappling hooks?
Oh, could you take a picture of that?
Just like this? I was gonna zoom out a little so you could see.
Maybe just a little so you can get some of the central part, but not too much, because those little hooks make it look deliciously evil. All right. There's some discussion about a Black Mirror episode. Sounds like a nerdy manga plot. There are a lot of okay, let's see. A lot of projects for that, but I was actually instead hoping to sync them to a LFO from the modular setup for a little something different. That was from OpenSet. Oh, the lighting you were working on for your microscope. Anakim says there are more diatoms, planktons in the world, so I think most likely they're not going to be a microscope. What about a mobile microscope? That'd be cool. maybe polarize only the light from the LEDs. Oh, you'd see some interesting effects. So there's cross conversation, sorry.
It's all right.
Look at that. That's just crazy.
Well, crazy view is what we get all the time around here, so. I've decided that I'm just going to have to live with my visual ASMR tag.
Mm-hmm. Embrace it.
Embrace it, yes, exactly. I will still resist the audio ASMR though.
That's just so cool.
Yeah, I wish I understood what was going on here, but, you know, marine stuff is weird.
Yes.
Oh, hello, Andrivan. I'm a diatom researcher, and I analyze diatoms for my work. But the stuff that we're doing right now is mostly for fun. Although I am kind of training myself marine diatoms. I mostly work in freshwater. So these are some samples that PacificPlankt, who's here as my guest today, as a disembodied voice, is responsible for collecting and sending to me, and then I place them in the Scanning Electron Microscope here in my lab. And we've been looking at some of the samples. She's been sending me stuff since, I think, October or something of last year, every once in a while. So broadly, I'm right now doing sort of just science outreach, and I don't know, this is sort of like fun for us. But a lot of times, things that we see here are somewhat related to things we also see in my samples. So either the structures or the organisms, as many of the genera do sort of overlap, but not all of them. So.
And also the some of the images that you share with me, I get to use in education and outreach here.
Right.
Doing general plankton education with school groups and others.
Right. So it's a nice sort of partnership that we have. And PacificPlankt is also a streamer on Twitch, and she streams from her light microscope looking at these same materials. So if you go back in time to March 1st, I think March 1st was the day you collected these. You could look at her stream, and you could actually see these organisms where they were collected live, the living parts wiggling around or crawling around or whatever they do, and living cells in the diatoms. So that's sort of I think that's a nice combination to be able to get the a sense of the living sort of plankton, and then we can't usually get that close with the living stuff, so she sends them to me afterwards in some cases, and then once they're dead, we can slap them on the SEM.
Dead things.
Yeah.
Anakim, Micah is not Mallory. Mallory is Igor, and Igor is not here.
Yeah. Oh, is Micah still in the channel? No.
Micah's in chat.
Yeah, okay. I wasn't sure. I hadn't heard from him for a while, so I wasn't sure if there was It didn't tell me he left, I guess, is what I'm saying. So. Ooh, what was that? What was that little guy I saw?
It was just there.
Oh. Oh, it's just a Odentella. The little kind.
Oh, they are cute.
They look like little... Oh, there's another one right here. They look like little... what the little thing that gets picked up by the claw in the Toy Story. There's like little aliens with the 3 eyes. If you just put the 3 eyes on it, right? They had little
There you
ears
go,
and
yeah.
antenna. They look just like this.
Yep. They do.
They're probably looking up right now at the SEM going, the claw!
The claws. The gun.
Yeah. Yeah, there's a bunch of them. There's a whole bunch of those little guys in here.
Yeah.
I'm always, there's so many big things that I always, like, overlook the little things whenever we look through the SEM. I'm always just like, oh, look at this huge thing that's taking up, you know, massive amount of space. And then when you actually get to the little stuff that's sort of hiding in the background is also kind of cool. So
Andrew Vaughn wants to know, are they all coated with metal, or is that not necessary?
everything in this sample has been coated with gold. Yeah, it's necessary for diatoms, but this sample is from the living material, so it was alive. We didn't digest this sample. I do have other samples on this stub that were digested, but I think this one is the living component. And so that requires me to coat them in gold or some metal, or they wouldn't be, they would get charged up. Yeah, so diatoms don't, because they're made out of silica, they don't conduct electricity very well.
I suppose that's a good thing.
I mean, not for the SEM, it's not.
And for the diatoms.
Well, I mean, silica is what the, like, microchips are nested in, right? So, as an example, because it's not conductive.
Anakin's worried we're never going to see that jellyfish thing again.
Well, it's on the stub, so I could go see it whenever I'd like. That's one of the nice
You can go
parts.
see it.
That's right. I did take pictures, though, so you could see the pictures whenever you'd like as well. We might never see anything similar to it again, but somehow I doubt that. I feel like lots of weird things. I'll continue to get samples from Pacific, probably, and then, you know, we'll see things again. We might find something else that's really cool if we keep looking.
Which one?
Which one what?
What was that?
I don't know what you mean, what was that? Are you talking to me?
There was a, I think it was a Catastrophe. It was just funny the way it was curled. It was like a little TIE fighter.
Oh, okay. Yeah. There are catastrophes all over this slide. Oh.
Yeah.
There's a Asteromphalus, I think. Yeah.
Anakin was worried you were going to throw the samples away. Once you make the stubs, what happened to the stubs?
There are like racks of stuff behind me that are filled with our old stubs. So actually everything that we've used on the SEM, we have here in our archives, even ones that didn't turn out very well. And at some point, I really need to focus on getting it organized. I keep thinking that I'll have Mallory do that one of these days, but one, she's very busy, and two, some of the stuff we don't have any place to put it because I need to make some more, like I use a drill bit and drill out some wood blocks and make sort of big storage things that we can store the stubs in, and I still need to do some more of that, so it's mostly my fault. But it's a disaster back there. I need to go through and like really organize it. So before it gets much worse, 'cause it's already at the point where for some of them the labels kind of came off, like you can't see it because of the gold coating. So for those, I'll probably need to stick them back in the SEM to figure out what they are, which will be interesting because we play this game sometimes, right? Where I just stick a sample in and then and try to figure out what it was. Okay, let's look around and see if I can find one that's a clean sample.
And then Andrevan wants to know how much of your primary research is based on the SEM and what other methods fill the rest?
It's a good question. So I would say I was able to do my research without an SEM for 2 decades. So until I actually got an SEM, I'm not quite 2 decades, but close. I think this is just a big piece of poop.
Oh, I want a picture of the poop if there's diatoms in it.
Only if there's diatoms in it?
Well, it's less exciting if there's...
If it's just organic debris?
If it's just, yeah.
I mean, that could be a diatom. Let's take a look. So I don't necessarily... Yeah, that's a piece of a diatom. I don't necessarily need to have an SEM, but I also, now that I have an SEM, can do taxonomy and answer and ask sort of taxonomic related questions better. And since we got the SEM, I've described something like 15 new species, and we're working on describing another 10 or something. So the access to the SEM, like regular access in my lab to an SEM, makes a huge difference with respect to like what I can do. It's not that I can't do my work. It's like now I have 2 avenues of research I can explore, and my students as well, because I train my students how to use the SEM, are capable of engaging and accessing, like, you know, I'm working with Mallory to describe new species of diatoms, and this summer we're going to do a bunch of research with students on the SEM. So they actually can ask questions or answer questions as well that they wouldn't normally be able to work on. And I think it opens a lot of opportunity for student research because you know, normally like science questions are a little bit too difficult. Like the time investment for an undergraduate is immense, but like if it's just on an SEM and we're looking at like the taxonomy of a diatom or something like that, those are questions they could answer. We could put the samples together, look at it in the light microscope, look at it on the SEM and characterize it, and could potentially publish it in the span of a couple of months. So that makes it something that, like, you know, my students could actually use in their research or be engaged in actual research, right? So for asking questions or answering questions for them, I think it makes a huge difference as well. And I have undergrads in my lab and graduate students in my lab, and I think that for both of them the SEM is extremely helpful. I would also say that it's opened some doors between me and colleagues because a lot of my colleagues don't have access to an SEM, so I can just say, oh, send me a sample, we'll put it on, and then I can collaborate with them. So it actually allows me to contribute to their success as well.
Cool. So our Artful Turkey was saying that this looks like what they ate for breakfast.
You ate poop for breakfast?
I don't think they realized that's what it was. It does have kind of a shredded wheat look.
Like a piece of sausage or something?
Yeah.
Where all the plankton gets melded together?
Yeah. Yeah, or the shredded wheat gets compacted, kind of granola-y.
Yeah. All right, I'm going to get a picture of poop for you.
Thank you.
It's a poop stream.
It is, but it's so cool. I see a lot of this in the plankton, especially so the way seasonally you get blooms of phytoplankton and then blooms of zooplankton, right? So one follows the other. And very often, once the zooplankton start to really ramp up, we see a lot of the poop.
Yeah.
And it's an indicator. It's one of the things that I notice as it increases. It tells me about what other things are in the water. So it's really cool tool to have.
This is kind of interesting to me as well because this particular piece of poop has gone through nitric acid. So because this is a clean sample, and
Is it?
I think so, and it actually sort of shows how even with like pretty strong acids, I mean, it was heated with nitric acid for like 2 hours, which would, I don't know, digest pretty much anything. But something's still holding it together, right? So that aspect of it is kind of interesting to me that, you know, like all the or most of the organic parts are gone, but it's probably because the acid can't penetrate as deeply into the internal parts. You know, if it's really compacted poop, and so it's still being held together. Maybe the outside parts, all the organic material's gone, and you can see the composition. Like that's a little Oligocyra valve, and I'm not sure what this is, but that's definitely a diatom right there. You know, you could actually look through the poop and maybe see what they were eating, which is kind of cool.
Yes. I mean, and actually scientists do that.
Yeah. Not me.
Not you, but other scientists do. So there was, let's see, there was a comment. Where was it?
Can we give a shout out to
Someone-
Artful Turkey, by the way?
Yes, we can. There we go. If you're a streamer and I don't give you a shout out, let me know, because I may not know you.
I think they're one of Jay Renzella's collaborators. They work together, and I think they share a Discord together.
Headshot specialist, yes, this is really poop.
Would I lie about a thing like poop? There, it just says poop right on the actual label, so... Yeah, I'm pretty sure this is a clean sample because look at how everything's like, you know, pretty clean. I don't see a bunch of gunk on everything, like usual.
Yeah, wow.
Let's see, I'm going to turn up the beam intensity so I can move around a little bit faster and see things still.
Headshot specialist says, poop looking like a cool celestial body.
In the right light, I mean...
Good news, everyone!
Hey, we got a new follow. I think we got 2 follows. The Techie Doc gave us a follow about 3 minutes ago, and the Buff Astronomer. Do you think maybe they mean buff like color or like strong?
I think strong.
Okay.
I'm going with strong.
Okay. They've been working out.
The Techie Doc says they didn't know that these kinds of streams existed over Twitch.
Well, on an SEM, this is pretty much the only stream like this on Twitch. But if you're looking for other people who stream from microscopes, there's definitely people who do this. PacificPlankt is also one of them. So I think I got her stream address correct in the title. If you might be able to click on that. So you see how it twists as it goes across the middle right here?
Oh, that's the one you were talking about the other day, the
Yes, Scoliopleura, I think is its name.
Scoliopleura.
Yeah.
Oh, so cool.
You see the twist though? It's like a torsion, like the valve's been kind of tweaked.
Yeah.
It's a little easier to see from maybe a little closer than we are, but it starts over here and ends up over there, right? So it's like doing like a twist, a very subtle twist.
Dance move. So Andron says, wow, that's very cool. I only very recently started working on an SEM, or a dual beam to be precise, as well, but I only use it to prepare samples and not really for acquiring data.
Ah. So, I mean, I think SEM's just a pretty cool toy to play with, to have access to as an instrument, because for my work, you can analyze diatoms on a light microscope, but I often compare a light microscope, like a transmitted light microscope, to an X-ray. So it would be like looking at everybody and everything through an X-ray and then trying to figure out like what they actually look like. So, there's a problem with doing things that way, which is that you don't actually understand what you're seeing all the
Good
time.
news, everyone.
That's a little piece of skeletonema that's fallen out of its colony. Right here. Its spines are hanging out, holding on to nothing. And this one too, right?
It looks like it. Oh, yeah.
Oh, it's definitely skeletonema.
Yeah.
That's the classic skeletonema sort of shape and structure for the spines and stuff. So, and that's a diplanese. Remember, I was saying that they occur in marine realms pretty commonly, and I've seen them a lot in these samples. So here's what skeletonema normally looks like. It's normally holding on to a neighbor, like this guy, lady, if you like.
Clones holding hands. So the really tiny ones are the really old skeletonema.
Yeah, a lot of the ones that we see on your streams are usually pretty small. Oh, what did I find?
What did you find? Oh, it's the triangle.
Triceradium-esque thing.
Probably. that one that I've been seeing. So I've been seeing them in little chains. The little triceradium chains. So cool. Open set. Yes. Like a Dorito. Anakin Luke redeemed. Sylvia draws you a picture, but asked if I would draw instead, and I said sure.
Oh, that's a great idea. I should make one. PacificPlankt draws you a picture, and then.
But only when my voice is here when I'm strict with you.
No, whenever they want, you have to draw a picture.
No.
I'm going to hang on a second. One, I gotta change my beam intensity down to the number I want, and then we're going to try to get this even better.
Areola.
Well, it depends on whether there's one or many. This is the same word. It's just plural and singular.
Areola is singular. Areolae is plural.
Yeah. See, it's still jogging a little left and right.
It is. Wow. I haven't seen it move that much in a long time.
That's because normally it's me using it and then me using it, and I get the beam centered and the wobble perfect, and then everybody lives off of my perfect beam, and they don't mess with it. I mean, if they're wise, they don't mess with it, I guess.
Oh, Binary Split wants to know, let's see, do you ever overlay microscopy and SEM images to make cool dual mode images? That's a neat idea.
I don't know. I don't know how to do that, actually. But I don't know if people do that. I mean, not me, but I've never seen anything like that.
So you know the images where they have like pictures of like a road from a long time ago, and you can like drag the slider left and right across the image?
Yeah.
It would be neat to do that with, live and SEM view.
Yeah, that would be super cool. See, this is what happens when I sit and tweak the image for a little while. That's just awesome. Those little covers on the areoli are super cool. Okay, let's, I'm gonna get a picture of our little Dorito. First
And
thing.
so those are the cribra on the inside, right?
Um,
Or
so the term for those is, I think those are called rota. They're, it depends on where the little covering is. If it's on the inside of the valve and it's basically part of the internal sheet of silica, it's called a cribra. And if it's wedged kind of halfway between the inside and the outside like these are, and they're attached by just little bars, so like the way that they attach, you can see that in here. There's like little tiny bars that are connecting, and then the rest of it's kind of floating out in the middle. They have different names. They're called vola and rota. They have like really specific, hang on. Let's see if I can find it in the glossary, because I sometimes forget them. Rota. Yes. A rota is a type of vellum, which is what all of these things are called, consisting of one or more bars across an areole with or without a widened area in the center resembling a wheel with spokes. So
now,
my
is that
brain
from the
remembered what it
diagrams?
was. Yeah,
Is that
that's
from Diatoms of North America? Could you pop the link into chat?
yeah, yeah.
That'd be cool.
There you go. So
you.
it doesn't. They normally have a picture with the database, but they don't have little pictures. But you can see there's a whole bunch of different types of occlusions, which are what they call the vellum. This sort of groups of occlusions. Cribra is from ones that are on the inside usually, with like little salt and pepper shaker heads. Those are called cribra, or cribrum, if it's one. And vola are like a sort of different type. Anyway, I should provide them with some pictures, because I actually am a contributor on this site, and they need some pictures of these things.
They do.
Vola does have a picture for vola, and we sometimes see those, but they don't have one for this one, so.
All right. So there were a couple of other questions here. Let's see. It was Andravon. Correlative light electron microscopy is very popular in my field these days. More with TEM than SEM, though. And they say, do you study how they build these crazy structures as well?
I don't, because that is like the polymerization process is sort of all biological, and I don't study like the physiometry or the physiology of diatoms. I study their skeletons and use it for taxonomic purposes, which I then use for sort of paleoecological information. So I'm more interested primarily in the types of environments that a diatom lives in, and then link that with a species, which I then can use for looking at the skeleton through time. So, I think the polymerization of silica process is really interesting, but a biologist, really a biologist would be giving you that information, not me. I'm more of an ecologist and not really like a cell level biologist, if that makes any sense. Look at this
Ecologist,
weird pour.
paleolimnologist.
Yeah, also sort of a taxonomist, and paleoclimatologist, and like I do a lot of things. So, but I leave the cell stuff with the soft parts to someone else. That's where I draw the line.
ASDFF says mad scientist, you mean?
A little bit at times, but I think you have to be creative to be a scientist, and it's underrated with respect to what people think of when they think of good scientists. They usually think of people who are like logical and rigorous thinkers, but I think you actually have to be creative in order to be good at science. I think it's actually a critical part of it is being able to not just see things, but to understand them. You need to, and you need to sort of get a perspective that requires creativity. So,
I was going to say happy scientist, not mad scientist, but that's...
well, I'm a pretty happy scientist, but that's because I like what I do. So, I like teaching, I like research. I could do without meetings, but the rest of it, I like what I do. So, in general, my job is fun, and I like being able to explore things, either in the real world or also in these sort of like microscopic world that we're in here. So I'm just going to call this one triceradium, even though I don't know if that's for real what it is.
We should ask Anna. Where's Anna?
You know, I haven't seen her on a stream in a while, but she was messaging me yesterday. She was congratulating me for getting my vaccination. So, so she's you know, she's around. She's just hasn't been on the stream. So. I feel good about the focus right now, though. I feel like I got it.
Yeah.
So, usually once I get it set up, get the stigmation where I want it and the wobble where I want it, then it stays pretty good for the rest of the time. So, like I said, I feel pretty good about it.
Well, I like it.
Well, that's two of us.
I'm
then.
pleased. Yay. And potentially 33 people in stream appreciating the clarity.
Right. Hopefully they do. I worked hard to bring you this sort of clarity. Oh, what did I see? We're a little too far out for me to catch what I was looking at. Maybe it was just some debris. It's hard when there's so many little circles. There's a lot of little circles in your samples.
There are... Oh, hey, Mind of a Snail is here.
Hello, Mind of a Snail. We have a lot of cool crossovers that have happened, especially recently with Mind of a Snail, and like P-Chops, and like you were you on there, Pacific, or did they had some of your images?
No.
Just had some of your images on there.
Yeah.
Yeah. And I think they've threatened to put some of my images on there as well.
Ooh. Mind of a Snail says, art and science together forever.
Yeah, that's how I feel about it as well. So, as somebody who obviously crosses that line frequently, in both my drawings and my photography and manipulation of SEM images, I guess, because I do post things that we collect here as images to Instagram. And I suppose I could do some of that. Oh, you beat me to it.
Gotcha.
I need to give you a little less warning. Now that you can hear me in real time, I have to be careful.
Oh, Andrevan wants to know, speaking of that, how do you do the pseudo coloring for the images in the slideshow on the right and on your Instagram?
Those are all done with a program called Adobe Lightroom, which you can get like a free version of that program, I think. I have a university license for the Creative Cloud, and so I use that on my iPad. So I just take these images, I dump them onto a USB drive, which I can then plug into my iPad, and then I just modify them primarily by changing the color associated with the highlights, the shadow, and the midtones. And you can use a lot of programs to just change those three aspects. And I do a little bit of cleaning up the images. I mess around with the contrast settings and the clarity, and I try to sometimes get rid of the noise. The SEM's a little noisy, so like relative to an actual camera, the SEM images have a lot of grain on them, and so I usually take them in to at least get rid of some of the graininess in the images, and then yeah, I just sort of play with it. I do sometimes then take those images over to Procreate, which is another tool that you can use with an iPad. So I have you have to buy that one, but and then I will sometimes select aspects to modify more directly using Procreate. So that's more like sort of selecting by contrast and making adjustments to specific colors, or by throwing sort of a gradient over top of the images. So it sounds like I do a lot, but it actually doesn't take very long to do. So for most images, because I have a photography background and I know I've done it a lot, I know what to do. The hardest part for me is sort of trying to make a diverse selection of colors that I haven't been using, like trying to change my palette, because I like the same kind of colors for different aspects of them, but I don't want it to always look like, oh, it's like this, bright blue and purple and something else kind of mixed together. So I have to spend a lot of time kind of futzing around with it to make it look different from the other images that I've already modified. So, are you drawing images? Or are you drawing for the stream? Is that what you're doing, Pac?
No, not yet. I'm just entranced. Sorry. I'm like, oh, wait, what's that?
Well, if you see something you want me to stop on, just let me know.
No, I'm just enjoying it so much. That's Bacteriastrum. That's what it looks like.
Yeah, that one's for
And
sure.
it's not an end. So their end valve of the chain looks different. It usually doesn't have the branching quite the same way on the Cete.
It also has some sort of a structure here.
Ooh,
I don't know what those are.
little newts.
Maybe the connecting spines, because they make colonies, and I couldn't figure out how the colony was being held together. But maybe those are the little spines that they use to hang on with. Maybe they just hold on through organic processes.
So it's just glue, like diatom glue.
Yeah, the normal sort of diatom glue. Here's some more. There's a whole bunch of Bacteriastrum in these samples. There's a couple of them together right there.
Yeah, wow.
They make just a mess when there's a whole bunch of them. They look cool when there's one. When they're all together, it looks like bramble or something. Just a mess.
Yeah. It looks like that in the light microscope too, because lots of stuff gets stuck in those branching setae.
Yeah. That's a Paralia, I think. Not positive though.
Huh.
Those, barrel-shaped things, there's a lot of them in your samples as well.
Yeah.
So, could be something else. That's Paralia for sure right there.
Yeah, I think of Prelia as more of having a weird See, I think that's Ellerbeckia, no? That's Paralia?
Yeah, that's Paralia. They have like these Colosseum-like structure.
Ah. Oh, I can see now. There's the tiny little spines interlocking.
Yeah, they're little U-shaped spines
Mm-hmm.
right there.
Yeah. There.
I'm gonna get it in focus one of these days. Yeah, so you can see it. They're these sort of little U-shaped, crenulate-shaped structures here that link them together like poker chips. But the little open windows, those don't occur in Ellerbeckia at all. So these little Colosseum-like structures, that's not an Ellerbeckia feature. They're smooth, or they've got little hexes over
Tiny
them.
little.
Yeah. So that's Paralia. Probably Paralia sulcata. It's the only one I know, and it's the one every time I look at any Paralia, that's what it ends up being, so. Oh, here's one of those little guys, the Dorito on its side.
Ooh. Yes.
Let's see, I want maybe 90? Too far. Trying to get it straight up and down for us. And then I can actually zoom in on one of this front edge a little bit better. Focus.
Ooh, look at that.
You see those port
those
covers
are-
are the same. The
Mhm.
same little rota port covers. And now I can, once I get it in focus, then I can move out a little bit and try to get it centered.
So Andrew is saying, how do these things get energy? Do they photosynthesize or do they eat? Well, they definitely photosynthesize, but there's nature finds a way to do weird things.
Yeah, most diatoms are photosynthetic, and most of them are obligately photosynthetic, but there are some diatoms that are heterotrophic. That means they can eat, usually it's like detritus, like they can consume detritus-like material. They don't really have like mouths, so it's more like acquiring nutrients and using that for energy. There's also, I mean, there's so many weird things in the microscopic world. There are diatoms that are like symbiotic with other organisms. Like dinoflagellates do this a lot, but I think there's actually even diatoms that are in a symbiotic relationship where they're like an endosymbiont inside something else. So I don't remember which one those are, but it's kind of weird because in the freshwater realms and in parts of the shallow waters of the marine realm, there's endosymbiotic relationships where the diatoms have something inside of them that's like a nitrogen-fixing bacteria. So all of the Epithemia, Rhopalodia group are like this. They have like specialized, I don't know, prison cells where they keep the cyanobacteria as prisoners that work for them. And then there's diatoms that are actually in that same setting in a larger organism, in some larger organisms, which is super weird to me.
That's crazy.
Yeah. It's like when Goofy has a dog and the dog is Pluto, and you're like, what? But Goofy's a dog, and he's got a dog as a pet?
Prison cells, says Andalor. And Andrew says, well, I mean, we humans do that too.
Unfortunately.
That is such a beautiful picture. Oh my gosh.
I do my best.
And it's quite small too. What's the size on? I can't see the size right now.
10 microns is the scale bar, and the total width is 38 microns. So that's the height, also the height in this case.
Yeah. Because normally I can just see them and know what they are, but I can't really resolve them, especially when they're alive. They're like little fuzzy
Good
green
news, everyone.
triangle-like shapes. Wow.
Sort of lost track of
Anything?
time. I was trying to figure out what was going on today. It's already 2:20.
Yeah,
It's almost noon for you.
it is. My coffee's gone cold, but that's okay.
Oh yeah, Spirit Walkers is a new follower. Thank you for following, and also ASDFF_. And I'm just gonna call this one Triceradium in Girdle View. Perfect.
So, Anna wants to know.
Good news, everyone.
Anna wants to know what material you look at. So right now this is diatoms from San Francisco Bay.
Yeah. I mean, I look at all sorts of things on here, but this is plankton. A lot of times I'm looking at sediment core samples, so we're looking at material that have been fossilized and sort of stored in the earth for centuries or sometimes millions of years. And then the diatom skeletons will be preserved. So we'll take them out in the form of a core, chop it up, and I can digest the sample and still get the diatom skeletons out of them.
I like stored in the earth. Yeah, we're just going to store those in the earth for now.
I mean, it's where I keep all my stuff.
Stored in the earth.
Well, more or less on the earth, I guess. That's
Still hoping.
really the way I think of them. They're archives, right? They're like a temporary storage place before I get to them, hopefully. Hopefully I'll get to them. Well, here's one of those giant odontelloids. Not a chain, but
Oh,
just a big,
yes.
big one. They're always covered with junk, even when they're clean.
Yeah.
They just got a rough texture, I think. Let's see. Let's move to a different one.
Okay. And binary split. It's from bay water collected near the Golden Gate Bridge in San Francisco Bay with a plankton net. There was only a couple tablespoons of liquid with diatoms in it.
Chaetosaurus everywhere, as usual.
Yeah. Seasonal.
Look at all the girdle bands,
Hey,
too.
Maui Sour.
Oh my goodness, Micah. Micah is gifting subs left and right, diatoms.
Uh-oh.
I know. 5 tier 1 subs to the community. Wow.
Yeah, thanks for doing that.
Newt, Newt. Aww.
Surprised us with an attack of subscriptions for people.
That is so cool. Anvan wants to know, is all the large round ones one single dominant species?
No, it depends, and I am neglecting a lot of these little round guys because we've seen them so frequently on the stream, and there's so many of them, but they're mostly Thalassiocyra, and which is a genus, not a species. And then some of them are also Coscinodiscus, which is also very common in these samples and in the marine realm in general. And this one is not quite a circle. This is Asteromphalus, and this is an internal view. So it just seemed really clean when I saw it,
It is.
and now I'm going to fix it. So the image is clear,
Oh, look at that.
and then we'll move back out. Actually, maybe I'll move back in so I can look at those pores, because I think I can actually see the pores inside here.
Oh, wow.
Those are
Right.
on the outside, but the
Mm-hmm.
the structure's sort of coming through as we look through the holes, right?
It's a little dark.
It is. I mean, I could fix that if I did something like this, and then this, and then this. So it'll just try to give us the brightness and contrast inside the little box, hopefully. And usually that brightens the image a lot, but it'll make the stuff out here that's lighter very light. So it'll look like it's glowing. But we'll be able to see the actual pores a little bit better.
Ah, there we go.
I think that's about as good as you can get without like destroying the outside image.
Yeah.
These have always been one of my favorite marine diatoms, and they still are. They're just so interesting looking. They're lumpy and slightly asymmetric, and I don't know, they just have like a weird, this sort of star shape is really kind of interesting.
Look, sand dollars.
Yeah.
That's cool.
Yeah, it's all right.
Now you have a T-shirt like that, or one of those images on your Redbubble.
Yeah.
If you really like it, you can check it out there.
The image that I used to draw them from, that I used as a reference, had junk over a lot of the middle part of it, and so I had to sort of just like guess what it looked like under the junk.
Interpret.
Well, we were seeing them very rarely at the time, and in
Yeah.
the samples, and so I didn't have any really good pictures of it, where everything was clear, So it was like kind of like the lower part down here was all junked over with stuff in the picture that I had, and so I just sort of used what was there on the other side to kind of predict what was going on this side, but was less than perfect as a result, I felt. So still looks pretty good, but could have been a little bit better.
Looks really good. Mind of a Snail says, yes, related to sand dollars? Question mark. So gorgeous. So they are not related to sand dollars in the sense that they're a single-celled algae and a sand dollar is an animal. But I suppose we're all related when it comes down to it.
We're all fish.
If you go back far enough, we're even, less than fish, more than fish. Which way? Less than, more than,
Equal to.
equal to?
Yeah.
So Andravon wants to know, it says, you mentioned earlier that you routinely describe new species. What do you typically name them after?
I try to name them, if I can. I have sort of like priorities, and if it's something that's really old that nobody is likely going
Good news,
to
everyone.
regularly see unless they're looking in the fossil record, I tend to name those after people. People who are scientists who are working in that area that are linked with the site somehow, potentially, or who had worked in there before I got there, or something like that. Because my higher priority, if it was like a modern species, something that people see regularly, is to name it after the shape that it has, rather than after a person. And the reason that I do that is because I want it to be something that you will remember the name because of what it looks like. So, we named something after sunflowers because it looked like a sunflower, for example, or some characteristic about it that is very distinct. So, if I can't do that, I will sometimes name it after a place. So if it's an endemic species, or we think it's an endemic species, I try to name it after the site where we found it. And I try not to do that unless I think it's an endemic species that we wouldn't see elsewhere. So then you would link the name together with the place, right? So like my strategy is based on trying to think about how are people going to remember this name, and how can I name it something that will stick the best with that organism. So that's sort of my priority. So I start with does it have a characteristic shape or appearance, and I try to use the Latin expression for whatever that is. And then if I can't do that, then I'll name it after the place, and then worst case scenario, I'll name it after a person. So for modern stuff, for ancient stuff, it's usually the reverse. It's usually people first, because I feel like sometimes it's an honor to work at a site where somebody else has already done a bunch of work like that, and I like to particularly do it if it's somebody whose papers I read a lot on that particular topic or site or whatever, or they're we named one after David Jewson because he helped me understand Aulacosira, so we wanted to name an Aulacosira after him, in part because I was a little confused why he didn't already have something named after him. I don't think he had any diatoms named after him, but he'd been in the field for 50 years doing incredible work. So those people I try to just sort of pick out and honor them with some sort of a name. But you can name it after whatever you want. You have the freedom.
Mind of a Snail. Yeah, Mind of a Snail wants to know, did you name one after yourself? Sorry.
That's the one thing you actually can't do. In the taxonomic literature for plants, which is where the diatoms are dumped, we follow the botanical taxonomic code. You cannot name it after yourself. And I would actually argue that I wouldn't name it after myself anyway. That's actually the thing that I'm least interested in doing. And part of the reason for that is it's cute to name something after yourself or whatever, I suppose. But I feel like that's nominating yourself for an award. You know what I mean? If you really deserved it, somebody else would name something after you. You wouldn't have to name it after yourself. So I aspire to be worthy of having something named after me, but I don't want to be the person who does that. So if that makes any sense. That's just the way I view, there's enough people out there naming diatoms that I'm sure eventually somebody will find what I do valuable enough to name something after me, but I don't want it to be me. So.
Cool. Mind of a Snail thinks more humans should name their babies after diatoms.
I don't know if I agree with that, but I'm not opposed to it. As somebody who had to name a human, I felt like it was actually really difficult for us to come up with a name. And in fact, I looked through for my daughter when we named my daughter. We could have named her after a diatom, but neither my wife nor I had any interest in that. But I looked through like every baby book name, and I just like hated everything except for like maybe 5 of them. And part of it's because my last name is Stone, so like I have to pick something that can't be turned into like a sentence, or a weird descriptor for a person, because they've already got Stone in the name. So, for example, Sandy would have been a really bad choice. Or I don't know if it's a guy, Flint. I feel like you could make really bad choices with the last name that's a object, and then the poor student is going to be, or poor child is going to be tormented forever by, I don't know, the Meet the Flintstones soundtrack every time they do anything. So, well, anyway, it's hard naming people.
It is.
It's easier for me to name diatoms, actually, because I can just look up something that I think is sort of reminds me of in Latin and then stick that on there as a name. And I've never had anybody complain about when I named something. I'm actually kind of waiting for that to happen, but it hasn't. Where like somebody's like, "Why would you pick this name?" But diatom people are generally pretty cool about stuff, and I think they don't care what you name things. So there's some pretty funny names in the diatom world.
Funny?
Yeah, like the name of the
See,
diatom is
now-
pretty funny.
Like what? What's a funny diatom name? Now I need to know.
Maybe I'll find some for you, and then maybe I'll share those with you. You're streaming on Monday, right?
Yes.
So maybe I'll show up and give you some of those on Monday. But this guy, David Jewson, that I was talking about earlier, he named a diatom like Comica as the last name, as the species name, I mean, because it looked like a person with their mouth open, like they were laughing. Just as an example, like you can name it whatever you want. But they picked that name because it's sort of like they thought it looked like a face, right?
Oh, wow.
But there's some that are actually pretty funny. So if you know the backstories, but there's a lot of diatoms that are named like Inconspicua, or like names where they clearly were unhappy with the diatom that they found, which I'll try to give you some examples of on Monday. I don't want to spoil them, but
Okay. Andrew Vaughn was saying something in chat. In the gene world, there's very funny ones out there, like Brunch Pilot,
Brunch Pilot.
which is a German word for crash pilot.
Okay.
And the gene was found in flies who kept crashing, caused by neurological defects.
Perfect.
See?
I would like to pilot some brunch right about now into my mouth.
Oh no, you didn't eat lunch?
Well, I couldn't have, because the stream started at noon, and it started at 1, and I have to get in, by noon if I want to stream. I've got to set stuff up. I have to apparently poorly set up the Discord channeling at least once. So we're currently looking, by the way, at the external view of a Casanodiscus, one of the round guys, and I just really like this crazy polygonal pattern with the little circles in the middle, and you can actually see underneath, like inside, in here. So these are an external layer of silica. You can actually see the basal silica layer, which is this one that's in here. Inside that little hole, there's another opening. So it's like there's a hole, and then in like kind of a chamber, and then another hole. And if we were looking at the inside of this diatom, which I think this is Perforatus, These would be the rim of portula. These are the rim of portula openings on the valve face. And there would be a cribra on the inside as well. So there's another layer of silica with a different type of occlusion over it.
Wow.
But you can see the basal siliceous layer down here, like inside. You can see those little openings that are like inside of the holes. And then the outer layer, which is this one, the secondary layer.
It's just so beautiful.
Well, I figured since I stuck us in the visual ASMR tag today that I should probably do some images that are kind of visual ASMR, like this one. I mean, I think all diatoms are kind of visually stunning at this scale.
Hey, Mama Bonbon's here. Hello. Did I miss you before? Mandervon has to leave and grab some food.
Well, thanks for
But
hanging
actually-
out. Yeah.
Yeah. Oh, that's so cool.
Hey, District 10, did you see you got a gift subscription? You can use the diatom emotes now. I think I saw that Micah had given you out one.
And you can use channel points to modify them.
What did you do to it?
What did I do to it?
To modify it.
Oh, with the channel points?
Put on sunglasses on my diatoms.
I like to flip them. I like to mirror them because then you can use them next to each other, especially the Suriella. Let's see here. Because then you can let's see. When it's mirrored, you can do them both ways. Like that, and they look like little wings.
Ah. Well, you could have had all four of them. You were so close. Could have had the other corner and made a perfect little box.
I could have. Still no Carethron, huh?
I'm not seeing any.
Man. Boozy.
Well,
Let's see, silly question. Just arrived. What are those perfect circles?
perfect circles are diatoms. We're looking at diatoms from the Plankton of San Francisco Bay, which are samples that were collected by PacificPlankt, who's also here as a disembodied voice.
Hello.
Which is better than earlier when she was here, but as a disembodied voice in my head and not for everybody else.
It's the ghost in the plankton.
Yeah.
Otherwise known as the text to chat.
Right.
Or voice to text. Text to voice. I'll get it eventually.
Well, I greatly prefer the version where people can hear you besides just me, so... Ooh, what's
Glad
this?
to be heard. Ooh.
Uh-huh. Plera Sigma.
Does it have a decussate pattern?
It does. You want to see it?
No, it's okay. I want to find Carethron. I really do. It'd be so cool.
Well, it should be in here somewhere. How frequently did it occur in the sample that you sent me?
That's a good question. So I would find it on at least once on each slide of live material. So not that frequently, but more frequently than something crazy like Arachnodiscus.
Well, I haven't seen any Arachnodiscus, so
I know.
I think they would be obvious in the SEM. I mean, I've seen them in the SEM before as fragments, but I think they would stand out in this set of round things. Oh, it's an external view of Asteropolis.
Actinopticus. Oh, no,
Also, there was
Asteropolis.
also an Actinopticus, but that one was Asteropolis.
The A diatoms.
There's a bunch of them. In fact, I think that's probably the most common letter for the planktic genera to start with in the marine realm.
Really?
Yeah, there's like Oliscus and Holocasyra and there's a whole bunch of them. Actinocyclus, Actinopticus, Asteropolis. It's like a song from what are those Tiny Toons? Did you watch Tiny Toons?
I don't think I watched Tiny Toons.
Oh, I think you missed out. That's actually a pretty good show.
I think I came just before the whole like that they were like the tiny or the baby versions of the older
Sort
tunes.
of. Yeah.
Yeah, I was in on the when they were just tunes
Oh, I
era,
mean, so was I.
and not the like the tiny versions where they like babyified everything.
Well, I had
What was
a
it?
I had a roommate in college who liked cartoons, like, all the time would watch cartoons. So I watched them because I was forced to.
You were forced to.
Well, I guess I could have left the room.
Yeah.
He would wake up every morning and watch Thundercats,
Aw.
and then that's how he started his day. So, which I was okay with. It's just that, like,
Yeah.
that's how I woke up as well.
Sometimes you just need Thundercats to get out of bed.
Yeah. Except for the one time that was a little disturbing, which is that he looked up at me because I was on the top bunk and he was on the bottom bunk, and he goes, "Chitara is so hot."
Uh-huh.
Hard to take him serious after that. Okay, let's move over to another stub and see if we can find magical, mysterious missing minion diatom. Oh,
Yeah.
there's another little triangle guy. I'm doing a good job finding the little triangle guys. Now we got an inside view.
An inside view.
Yeah.
I don't think we've had an inside view yet.
No, we haven't.
Ooh.
See, I'm doing a great job of finding Triceradium. If I do say so.
Well, you're doing a brilliant job of it. It's got the there's like a rib holding, kind of going across this corner tips.
Yeah.
Because we can kind of see that through the external view.
You can. And then these things, probably not obvious to you, but those are Rimiportula, for sure.
They're the mouth.
Yeah, they got a little mouth on them. Got a pretty mouth on them.
It does. Can you take a picture
Of just this, or of the whole thing?
of the whole thing?
Yes, I was planning to do that.
Thank you.
I don't know, I thought maybe I could get that in a little bit better, but I don't think I can. This I can, though. That looks okay. More Doritos. Only inside Doritos.
It looks very architectural, the inside.
You mean with this sort of costy, the dividing ribs?
Yeah. And then it's like there's a kind of a ledge around at the very corner that reaches over.
This part. Like these ones? Is that what you're talking about?
Yeah. Yeah.
Yeah, this is called a pseudoseptum. I think it needs to be brightness adjusted, but otherwise is looking pretty good. I hear
So if
pencil
that's a
scratching.
pseudoseptum, I know. So if that's, I'm taking notes. If that's a pseudoseptum, what's an actual septum? Like, have we seen an actual septum since now we've seen a pseudo one? And how do you tell the difference?
Pseudoseptums are attached to the actual valve.
Good news, everyone.
The valve. So on either end of the diatom is the valve, right? So in between is girdle bands, and some diatoms have extra pieces that are between them. And so if you think of a diatom like a giant Dagwood Bumstead sandwich, some of them also have like a lettuce layer and a meat layer, right? And when they have the extra layers, if they have a structure that's like that, is called a costi, or it's called a septum. So when it's on the valve, it's a pseudoseptum. When it's off of the actual valve, but internally present, then it's a septum.
Huh.
It's just a technicality as to where it is.
How it attaches.
Yeah, like on this one, it's actually part of the valve. So
Yeah.
you wouldn't mistake it. I'm going to try to
So here's a
brightness inside
ahead.
here and see if that helps. It might make this a little blown out, but I think it will look better than... This is still looking pretty dark in here.
Bluesy says, and here I thought the middle of the nose was a septum.
It is. Diatom names often have other human body part names that they're related to. Well, this looks really good, but I wonder what it looks like when we see the whole thing. Oh, it'll just be bright. That's okay. I feel like it's better to have the main part of the diatom in the right, like visible, and the outside edge be like glowing than it would be the other way around. Maybe it's a little too bright though. Well, what do you think?
Something in between. Something just like...
Oh, forcing me to do it manually, I see. Oh, that's weird. I have the brightness all the way down. It doesn't seem to matter.
No.
It's the contrast that's all the way up. That's why.
Harry Potter says, what is it a scan of?
Harry Potter's here?
Harry, well, yeah. And Ram's Reef?
Are they going to, like, do magic for us?
Let's see, hold on.
Alright, let's, I think this is a little bit in between. At least you can see some of the... Glows a little bit, but it's a little dark in here. Well, we'll run with it, and then... my other option is to take two pictures, one where the middle part's exposed and one where the outside is exposed, and then, like... stack it, or I could have it where it's a little underexposed and then fix it with Photoshop. So
Harry Potter says I thought you were doing the magic.
we are looking at the diatoms from San Francisco Bay. This is the diatom triceradium, or that's what we're calling it at least. And it's an internal view of the diatom. So the diatoms look a little bit different from the inside and the outside, but this is the skeleton of a diatom. Their cell walls are made out of silica, which preserves and makes skeletons in after we've processed them. So we're looking at it in the SEM. And it's slightly overexposed because I want to actually be able to see the inside of the valve. Which I think I did an okay job with, but needs to be toned down.
Oh, it looks good. And Jergling's here.
Hey, Jergling, how you doing?
And who's it? Is that skeleton or diatom? Skeletor, the diatom. Sorry.
I don't think this diatom was on He-Man as a villain, but I suppose it's possible.
Oh, this is so cool. This is the first time we've seen the inside of it.
Yeah. Look at those giant Rumiportula.
So they're not mantle portula.
Nope. They don't appear to have any of those. It looks like they just have Rumiportula.
Got it.
But I can't see under the pseudoseptus, so I could be wrong. But it doesn't look like it. This is Triceradium internal. And, I mean, we could look around for some more of them and see if we can find a... Let me fix this first. See if we can find a view where they're at an angle where we might be able to see into the... under the lip. But at least for now, it doesn't look like they have anything other than the Rumiportulas.
And Harry Potter says, always wondered what does a normal tree leaf look like under an EM scope. Could you do that?
Well, I know that we can do it because we have actually looked at tree leaves under the SEM. That's something that we did quite a bit in the fall. We've been looking at sort of a whole range of different things. I have some undergrad students who would just go out into campus and go grab some things. So mushrooms and tree leaves and plants and whatever. And we'd put those on the SEM. And we do that occasionally here as well. So you could probably check some of the old video on demands. Or if you can't find them, you might go to my YouTube channel where I would have stored them because it's been longer than 2 months. But we will do it again. We will, I think now that it's starting to not be covered with snow all the time, we'll probably be doing some more pollen. And I had this crazy idea in the fall that when the real pollen season gets here, that I might just take an SEM stub and mount it onto my bike and then go ride around like one where I do like a ride to school, and then one where I do like I ride around the stadium here at Indiana State, because our stadium has every tree from Indiana planted. There's like 130 different kinds of trees in Indiana. They're all planted on around our stadium in one little area, and so I thought it would be kind of cool to like just open up like a little bit of tape and ride around the stadium a few times on my bike and try to capture all of them, and see what ends up on the tape, right? And I can just put that directly into the SEM, which I think would be kind of cool. So it's this guy.
It is that guy.
It's the Katasaurus cyst for Didymus, right? I think.
I don't know. So the more I look at it, the more it confuses me. Because there's another one that has something. Oh, so there was a question. What is your YouTube channel? Tom's Attacks. People can find it. Do you have a YouTube?
Yeah, you can just. It's just Diatom's Attack. If you search that, you'll find it. Also, I've been working on a side project through another group of people, where we do lectures and things through Spirit University is the name of the channel, and I've been doing lectures as a VTube character named Dr. Mo, and you can also find that on YouTube. So I've been doing lectures about cool stuff. I try to keep it separate from what I'm doing here, from my Twitch channel, but if you're into VTube characters, or you want to see me give a lecture about extremophiles or hydrothermal vents, both of those lectures are up. And then I've been sort of channeling my late night microscope streams as my office hours for that character, which is Friday nights. I do a little late night hangout on the microscope, on the light microscope, not the SEM. But been doing that on my YouTube channel with Dr. Mo as well.
All right. Ramsreef, he's a VTuber. Okay. So it looks also a little bit like the Katasaurus radicans.
Oh, not a cyst?
So here's a question. Well, maybe not. See, that's the thing, right? So this is cleaned. So it's not in a chain. But it says chains straight or slightly curved, twisted about the chain axis, setae arising from just inside the valve margin, all bent out transversely, intercalary setae with hair-like siliceous spines. And it seems like they've got hair-like spines on them.
Yeah, they look like little roots.
Aperture is narrow. Yeah. It says aperture is narrow and elliptical with central constriction.
Aperture.
Aperture's narrow.
Is that where the setae enter the diatom? I don't know what that term means.
Sure.
I don't know what an aperture is. I didn't think diatoms had apertures. I thought cameras had apertures, and chrysophytes have apertures. Mollusks have apertures. I didn't know diatoms had an aperture.
Maybe it's the name for where the setae enter.
Must be.
The valve. Yeah?
Must be.
Do you think we could see it on this one?
Well, we'll see something. I don't know how well we will be able to tell what we're seeing, but I mean, is that described from the SEM?
I don't know. It's
because I don't think you could see that in a light microscope at all. You'd be able to see this sort of like long hairy setae, but I don't know that you'd be able to see the apertures themselves.
Well, now I'm curious. It doesn't specify.
Well, I'll go look. They look kind of pinched.
So maybe it's Katasaurus radicans.
Radicans. Well, I got you a nice picture of it, so...
It's very cool, my goodness.
You could at least look at it all you like.
Over and over.
I think there's a just to the right of this image is where the image is taking place, rather, is the Thalassiocyra weissflogii too. I saw all the central tubes sort of sticking out. Thought maybe that would be kind of cool, because I think it's an internal view. We'll go look there next.
So look at that one setae. It's got all these little bits, comes out, and then it kind of folds down over the top of a piece of junk, and then out along the edge of that other diatom. That's so long.
Yep.
Harry Potter wants to know, what's the most mental, horizon expanding thing that you've seen under the SEM?
Oh, I don't know about that. That's there's a lot. I mean, I don't think that's weissflogii. I think it's something else.
Yeah.
Those are.
It's probably Thalassiocyra.
Rimiportula, though, I think. I don't know what's going on there. I think that's a Rimiportula, though. I'm a little confused why it has a whole bunch of Rimiportula in the middle. I also am not sure that that's... Not sure what's going on right there. Because... that looks like the outside of the diatom. Is it inside or outside? If it's the
inside.
If that's the inside, there are no strutted processes at all.
You know, it's really funny. I just realized I was tilting my head to look at it, and I looked and I saw you were
I'm trying to figure out what's
tilting
going
your head.
on. If this is the inside, and there's
Yeah.
no strutted processes, there is, however, that's a Rimiportula out here on the margin, but there's no strutted processes. So, nothing. So, this can't be a Thalassiocyra. So, but that means
Anna.
it only has Rimiportula. Here's another one. Oh no, that's a piece of junk. That's not even a Rimiportula. I think that's just junk around the margins. But it does have this in the middle, which is super weird. Which is like a whole bunch of Rimiportula together. Crazy.
All right, I think there's a picture of that in my book. Let me look it up.
Oh yeah?
I think maybe.
Okay, I'm going to go back and look for this aperture structure we were talking about, because I forgot.
Cool. Thank you. And I will see if I can find. Ooh.
I mean, I don't know. They just look like V-shaped. But it does kind of like... I mean, it's so weird. Oh. I can't see anything special.
No,
No.
bummer. It's very cool, though.
It's a very devilish looking diatom.
It is. Ring of Fortune is junk. Says Mindolator.
What?
I think it's like Rimiportula.
Oh.
Ring of Fortune.
The Rimiportula is junk? Could be. Some of it could be.
So there were diagrams of.
I like that name, though. Ring of Fortune? That's a good autocorrect.
What is closed captioning? Oh, it's what closed captioning says. Nice.
That's the best. I have this for classes where I use the closed captioning and it tracks what I'm saying, but it's not good with science terminology, obviously. And some of the best ones I used to, like whatever it would come back with, I would copy them and paste them into like my Facebook page for my friends to see like the terrible translations that it was doing. Because some of them are pretty funny and borderline vulgar.
All right. S. What does the S stand
What does what S stand for?
for? S. It's the so there's a little drawing here, and it's an S. Stellaris. I'm like, oh, here we go. Stellarima has an interesting arrangement of Stellarima. I've never even. What?
Stellarima.
Yeah.
Okay.
I don't know.
Ooh.
I'm trying figuring it out.
Ooh.
Oh, it's clean.
What's going on here?
There.
Hello, weird little hairs. What the heck?
It's growing a silica parachute. It doesn't want to say.
What the heck? Is it on both sides?
I don't know.
They're here. It's little hairy. It's got a little mustache. Look at the top of these little antenna structures. These are also super cool. It's like a little
Oh my gosh. They're not just forked.
three-prong toothed openings.
Wow.
These are crazy diatoms. And so these should have a celly on the ends of these things. We can't see them, of course, because
Yeah.
it's right here. It's like pointed away from us in the camera. Well, not camera, but SEM.
Oh, look at that.
I'm trying to. Let's see if I can. Get it to be a little bit better. That's about as good as I think I can make it.
That's so cool, though. Wow. Oh,
Let's
that's just
see.
so crazy.
If we do that and do this.
Hairy shoulders.
Man, that's super weird.
Yeah.
Well, I like it when a diatom comes with a beard. It's a good look. I like a strong beard game, no matter where it is.
Okay.
Let's It's looking pretty sharp.
It really is. Wow.
All right. We'll just take a picture of this little beard, and then I'll get one of the whole valve. And I can maybe see what chat's been saying. Hairy shoulders. Craziness. Harry Potter wants to know, what does human skin look like under the SEM? And is there a video for that? It turns out that I have not stripped skin off of any person, Harry, but... and I also prefer if nobody donates pieces of their skin for me to look at in the SEM. But let me see about it. Maybe I can get some of my own skin, you know, like from a blister or something.
You get sunburn. You might peel.
Yeah, or we'll see if I can find some of my own. We'll put that on there if you're super interested.
Oh, wow.
It's a good looking shot.
It's really good.
I'm glad I spent a little bit of time at the beginning of the screen cleaning up our image, because these are some good ones.
Yeah.
Sunburn for science. We have to get enough sun for me to get sunburned soon, in order for that to happen, I suppose.
I'm trying to figure out what that thing was in the center.
Of the round one?
Yeah.
Stellarima one?
Yeah, yeah. Alright, I gotta look it up. See if I can find it. Not just in the book.
Are electrons teleporting from the hairy thing to the microscope? Well, they're not teleporting. They are just moving normally, but they move pretty fast. So I would argue that they are... I don't know. What is this thing? Hemialis? Odontella?
Odontella. In my old book. I will find
I'm going to call it hairy shoulders.
Call it hairy shoulders. I think that's the best bet.
Yeah.
So I'm going to say the Odontella that was... Because there's one that's on its own. I think it's Longicursus or Oriata. And I don't know... Let's see, hold on. It's got the short shoulders. Oriata. Probably. No. It's just wild.
Short shoulders.
Yeah, but see, but the it looks more like Longicursus. Longicurus?
Good news, everyone.
Let's see. Okay, so
let's see, where do I want the...
maybe that.
Maybe there?
Hmm.
I think that's as good as it's going to get.
Yeah. It's gorgeous.
So the
Good news, everyone.
the way that the scanning electron microscope works is that there's an electron gun at the top of it that's firing electrons down on the specimen, and the beam actually hits the sample, and some of the electrons from the electron beam will knock electrons out of the sample. And so what you're actually seeing are those electrons basically bouncing out or being deflected out of the original specimen. And then if you look at this thing that's right below me down here, that's the inside view of the chamber. So the little cone-shaped thing is where the gun is firing onto the sample. The sample is on the little stubs, and then the electrons are hitting it and going to this thing that's sort of over here in the corner that looks like a... Sorry, wrong corner. It looks like a little grating, and that has a positive charge. So the electrons have a negative charge. They're drawn towards it, and so they're not actually teleporting, but they move very quickly. And then it gradually scans across the image back and forth. So the image that you're seeing, the one that's being made for you, is constructed. It looks like a photograph, but it's not using light at all. It's just using electrons that are scanning over that sort of microscopic surface back and forth. And when it does, it captures how many of those electrons are hitting the sensor at each one of those pixels, basically. And then it provides a brightness value for that. And then basically as it moves, it changes the brightness, and then it creates a picture. So... And
Can a normal man buy an electron microscope?
well, I'm a normal man, at least by all accounts, and it's expensive. Let me put it that way.
There's no government restrictions against people buying electron microscopes.
Correct. You could own one if you have like $150,000 or something. If you want to sell your house and buy an SEM and live inside of it. I mean, some people's houses are worth way more than that. And yeah, you could get one. They're expensive. The cheaper ones are something like, I want to say $60,000 or $70,000, but they don't do as good of a job with the images, and you know, you'd still have an SEM though, so there's that.
Gov says, so the microscope is firing electrons at the hairy thing, and some of the electrons bounce back, and those get detected, and a picture is formed.
Yep, that's it. So it's, I can show you some like sciencey diagrams, but they're just going to show you the same thing. So that's basically how it works.
Good news, everyone.
Oh.
Ooh, that was really cool. Sorry, noises in my house. It's lunchtime. Sorry.
We got follows from Discrete Games and Foomp and Attila here from Italy, apparently. Harry Potter.
Good news, everyone.
Guy equals 8 pig, and art of DHT. So thank you all for following.
Speaking of lunch, are you going to get some lunch soon? You've been streaming
Oh
an
yeah.
extra half hour longer than I thought you would.
I usually try to end at, there's another ode on Tella. I usually try to end at 3:30-ish. So maybe I'll find one more and then get a picture of it, and we'll call it a day. And then I'll...
Can we find Carethron? I want to find it so bad.
Well, I can't promise anything. With respect to what we'll find, I've been looking,
I know.
so, you know.
It's so cool. We found such amazing things.
Yeah. I mean, there's lots of cool stuff in these samples, and that makes it easy to find them. But a lot of times the SEM's like a snark hunt, you know? You're out trying to hunt the wumpus, and sometimes you just can't find it. So, and that's actually probably the only thing I ever find even remotely frustrating about using a scanning electron microscope is that it's hard to find what you want, and then usually when you find it, it's covered with junk. Or what was that noise? Was it a cheer? Oh, thank you for the cheer.
Yeah.
Yeah, so sometimes when you find it, it's covered with junk, and then it's like, oh, like I found it, but it's not a good picture, right? So,
And Harry Potter wants to know if you have an SEM in your house or in an education institution.
this one is in my lab. So this is my scanning electron microscope lab. That's a radiolarian. And there's a really cool ditillum straight up and down into the camera here. Straight down on it. No, but I have microscopes at my house. I am just a humble scientist, and I can't afford to have an SEM in my house. I would get one if I could. In fact, when people used to ask me, what would you get if you won the lottery? I would be like, oh, I'd just buy a bunch of SEMs. Like, I would buy a bunch of SEMs, and then I would hire a bunch of my diatomist friends, and we would just look at stuff in the SEM all day. That's what I would do.
So cool.
If I had, I don't know, millions of dollars that I could just throw at it, that's what I would throw at it. So the nice part is I don't need millions of dollars to do that. It's also part of my job. So get yourself a job where you think that's what I would do if I won $1 million. That's a pretty cool way of looking at it, right?
It's a really cool way of looking at it.
Because then I like what I do enough that basically, I mean, if I got money, I would keep doing it. I wouldn't just like quit my job. I think I would just do what I wanted to do with my job a little bit more, and try to make science more accessible to people, and look at stuff in the SEM all day long. And I guess I might still want to mentor students and do research, but I might cut back on the teaching quite a bit.
You could fund your own research.
I could, for a little while. $1 million does not get you very far in science, so.
Start your own foundation to fund your own work.
Yeah, that's what I would ultimately probably end up having to do with it. But I don't play the lottery, so I'm not going to win the lottery. But if I did, you know, that's probably where I would go with it.
Oh, look at that.
Then I could also support some of my friends too, so that would be fun. Let me know if you want in, if I win the lottery pack.
Oh, if you win the lottery that you don't play, I definitely want in.
Okay. You might have to, I don't know. Like, I'm going to sit at the institution. I probably am not going to move to San Francisco, so not sure how you're going to manage. I guess we could always just have you come visit all you want.
Yeah, you could have a satellite office.
Oh, I see.
Right, for coastal research.
That's actually not a terrible idea. It's not a horrible idea. All right, let me rotate around to 3 and see if there's something cool on 3.
Okay.
Whoop, here we go. Oh, this is a live sample.
Oh.
Well, it was live. Now it's not. I can tell because everything's in chains. So there's like a Stereonelopsis chain, and then there was a Plesiocyra chain over here. So you can tell right away. Here's a big Cattosaurus chain that I'm looking at, like material that was collected that hasn't been processed.
As in not boiled in acid.
Yeah, yeah, yeah. Not boiled in acid. There's some. Oh, this is the one with the giant diatominate that you zoom out, you can get the whole thing in. Here it is.
Oh, that's right. It's huge.
Big long guy that distracted us from a previous on a previous stream.
That was massive. I saw another one of those in my live sample yesterday.
Oh yeah?
Mm-hmm.
You went out and collected diatoms and other things yesterday from the Plankton?
No, I had leftovers from teaching.
Oh,
I
okay.
was helping out, bringing the microscope world to students doing distance or remote learning.
Mm-hmm.
They haven't opened any schools in San Francisco.
Mm-hmm.
And sometimes I bring plankton on my microscope via Zoom to classrooms around the bay.
Why just around the bay?
Because there's only so many hours in the day, and those are the people that would actually have been coming to the visitor center at Christie Field for the local National Marine Sanctuary if there hadn't been a pandemic. And so because they already had, they would normally be there with their classes in person. We get to be there virtually for them.
How many schools? So you do these regularly, right?
Yeah, well, I help out regularly, right? It's not my job. I'm a volunteer, and I don't actually know what the numbers are because I don't keep track of that. There are people who are paid who keep track of all of that amazing information. There's hundreds of school kids that go through the program that we digitally visit their classroom.
I found the other silica flagellate. Here.
You did?
This one. The four-cornered one.
Crux. Dictyota crux. Erg. I can never remember the Latin names.
I don't know. This one's
here.
Got four edges, and the other one has like 5 or 6.
Yeah, so does it have a nubbin in the middle?
Yeah,
there's one that's...
It's got something pointed out at us, like
yeah,
right there.
Yeah, so maybe it's not crux. Huh? No, it's not crux. And it's really square.
Yeah.
And jaggedy.
I think
Staurodon?
I think I saw the 5-pointed one over here. Somewhere just on the edge of this field of view. Because I thought I saw both of them at the same time.
Yeah.
Oh, here it is. There's one there, and there's one there.
Silica flagellates.
We're not going to pay attention to those guys, though.
Oh. Oh. That's okay.
I got pictures of them.
I know where they are. On a stub in Indiana.
Well, that's also true. I can always come back and revisit any of these.
If you have time. Time is the one thing it's the limiting factor.
Well, that's always the case.
Hmm.
I never have time to do anything.
But you do so much.
I know, that's some sort of weird... How does that work? This is another triangle guy.
Inside, outside. Inside.
I'm not sure what that is. It's a different one.
No, really?
Yeah.
It's more pointy.
Yeah, it's got protracted ends. It's a different species. I don't know if it's a different genus, but it's a different species.
So there's 2 species of weird triangle things that are small that I can't see very well.
At least.
At least 2.
Yeah, at least.
Oh, so cool.
That one's got a cool little tube sticking out.
Huh. Thalassiocyra E.
Yeah, it's probably Thalassiocyra. I'm not seeing any little minions with hairs sticking out in every direction, though.
I know, I'm not either.
Well, we tried.
We did. Valiant effort.
It's just the way it goes. Sometimes
Yeah.
sometimes the snark gets you. Sometimes you get the snark.
But there were so many really beautiful things today. Odd things that I've never seen that close.
Yeah. It's fun. I'm always like, whenever we look through these types of things, I'm always looking for those little dinoflagellates and things we don't usually see intact as frequent.
Mm-hmm.
Usually they're just blobs. Covered with boogers.
Yeah. Sounds like marine plankton. It's not animals, blobs covered in boogers.
Look at this one.
Oh, yeah. There it is.
That actually has a lot of ups and
That
downs.
has more.
2,
Yeah.
3, 4, 5, 6, 7, 8.
Yeah, the last one was 6.
Yeah,
And then this one's 8.
it's got a lot.
It does.
We didn't see any of these in the digested part, so I'm gonna get, maybe this is our last photo.
Okay.
Once I get it into focus, you can see it's covered with, like, boogers. It's got
Life stuff.
life boogers on it. But we'll make do. Sometimes it's good just to have a picture of something weird like this. So at least you got one of them. Even if it's covered with boogers.
Yeah. Oh, that's a lot. So are they different species or different ages? Or did it, like, make a mistake?
As a different species.
So the species determines the number of ups and downs?
I'm pretty sure. Yeah. That's not like the normal one that we see, which is like Actinopticus syrians or whatever. It's not that one.
No.
It's something different.
It's different. But what is it?
Well, you got the book.
I know, but I don't think it's in my book.
I don't know how to help you then.
I don't know how to help me either. If it's not in my book, what do I do? Where do I look? That's so frustrating.
Okay. So here's the point where I should say thanks to everybody for hanging out with us, and especially for PacificPlankt for struggling through our early attempts to get sound to come out of the machine the way it's supposed to, and for Micah for helping out with that as well. And I will be back on, I think, Wednesday. All things equal, I should be able to get another stream in on Wednesday. I don't know what we'll look at. I think maybe Laura and I will be looking at some stuff, but I don't know for sure. And then, so you should check out PacificPlankt. She's going to stream from her light microscope on Monday night, and starting around midnight Eastern, or whatever that is, 9 o'clock on Pacific time. And
Yes.
and maybe we'll see some more cool things crawling around in her samples or floating around in her samples. And I should figure out who we're going to raid.
Yeah. Thank you so much for having me. This was a blast. It's always such an incredible treat to see these organisms so close and in such rich detail. It's just, it's amazing.
Yeah, it's pretty cool. Who to pick? Maybe we should go raid Seek Ye Wisdom, who is playing a retro game.
Ah.
Oh, they've got a Be Right Back screen.
Uh-oh. Last Miles is messing around with Linux, apparently.
Okay.
But
Well, we could definitely go get Last Miles.
and OpenSet says if you don't know who to raid, Dr. WD-40 might be a good one. He
Yeah.
says he's birding.
Oh, he's
Oh
birding.
my god, not earn 9 points.
Birding would be good. Oh, he's doing total outdoor stream, huh? Okay. Let's go get Dr. WD-40 then. That's fine. I like birds. Oops.
Birds are cool.
I can't wait till I'm able to go out and do some more
daggone it.
birding.
Is it really going to hide from us in there? I think so. You know what? Let's check this different angle.
All right. We're all
Find
set
out.
up. So thanks everybody for hanging out with us today, and for all the follows, for Micah, for the community subscriptions that you gave out, and for Mindolator, who's asked me to have Sylvia draw them a picture. I'll see if I can find her when I get home and have her draw you something, and then I suppose for Anakin Luke, I'll make PacificPlankt draw you something and stick it in Discord, in our Discord. So you can
And
check
if
it out
Sylvia
there.
doesn't feel like drawing, I got her covered.
Yeah, okay, good. Perfect. All right, so we'll go raid Dr. WD-40. He's doing some birding, and we'll catch you guys next time. Yeah, the stream's over now, Mr. Crab. Sorry about that. You just missed it. We'll be back on Wednesday from 1 to 3, so you can check us out then as well. All right. Thanks, everybody.
Goodbye.
Goodbye. Okay.
That was fun. That was so cool.